All right, let's go through the announcements for today. Test one, answers on my classes, just so you can kind of compare your answers to the ones posted on my classes. Then we have a small homework assignment due on Friday. I promise you it's very small, okay? So this homework's gonna look a little bit different than your other homeworks, okay? So I know WebAssign is kind of awful. So and I know that there's WebAssign graphing questions, and I don't want to give you those graphing questions. So if you go to the home page here and click on assignments, you'll see homework 4 up, okay? And it's not on WebAssign at all, okay? It's just gonna be this PDF, okay? And it's literally 3 graphing questions, so very, very short. I think it took me around 5 minutes to get it done. So not very big at all, okay? What you'll do is you'll just either like do it on your iPad and turn it in on my classes, or take a picture of your graphs and send them to me on my classes. There's like a little option for you to turn it in through there, okay? Also on the announcements, we do have a quiz on Friday. I think what I'm gonna do for this quiz is we have some common functions that you have to memorize. I think I'm just gonna make it sort of a quiz on just memorizing how to graph those, being able to plot them on the quiz. Okay, and I also put up a extra credit, oh no, an extra credit opportunity for test 2. It's very similar to the one for test 1. So if you go down to assignments again and scroll all the way down, you can see like the directions for it. Okay, so if you want to earn an extra 5% on test 2, you'll have to do this assignment April 14th, so the day before test 2. And what you'll see is I've kind of changed up the modules tab. Okay, so if you go back to the home page and scroll down to the ungraded practice problems with answers, up top, I put a little header saying test 1 worksheets, okay? So everything under this header, not for the test 2 extra credit opportunity, right? You're gonna have to scroll all the way down to test 2 worksheets, okay? These are the worksheets that I'm going to be using for the extra credit, okay? So do 5 of the worksheets that will end up underneath test 2 worksheets, and either turn them in on my classes or just show them to me in my office or after class or something. So this is very important for your quiz, because this is probably what your quiz is going to look like. But we went through yesterday very briefly some of the most common functions in the graphs, right? We did the constant function, the linear function, the quadratic function. And I told you that it's very important to know, one, the shape of these graphs, so like what they kind of look like overall. Also, it's really important for you to know like the very basic points, okay? And by basic points, what I mean is kind of what -1 spits out, what 0 spits out, and what +1 spits out.
Does the linear function, is it always going to have those 3 points?
If it's y equals x, yes. But we can do things to that function to make it have different points, right? Like when we did graphs of lines and stuff, some of those didn't have those points, right? But we'll get into like shifts and transitions. Okay, so we have this function, and I kind of pointed out 3 points pretty much for every function. You should know what -1 spits out 0 and +1 spits out, and you should draw it really clearly over. So we stopped with the quadratic function. I also gave 2 optional points on the graph that you can draw to make it look really nice. But I really only required you to know the 3 ones at the bottom. Okay, let's go on to the absolute value function. Okay, so now this whole idea of the graphs of functions isn't for you to memorize the points, right? Like not -1, 1, 0, 0, 1, 1. I'm not telling you to memorize the exact coordinates for every single one, but you should be able to make an X and Y chart and plug in some values. Okay, so here we have the absolute value of X. What do I get when I plug in -1 for X here?
positive one, right? The absolute value of a negative number is its positive value, okay? Plug in 0, you get 0. Plug in 1, you get positive 1, okay? So I'm gonna plot these points. And does anyone know what the shape of an absolute value function looks like? Yeah, it's a V shape, right? So even though it has the same basic points as the quadratic function, it's going to look more like a V shape than a parabola. Okay, so it's going to look more like this. Okay. Any questions on the absolute value? Oh, yeah. Oh, for the quadratic, yeah. So the points are going to be the same for the quadratic and absolute value. They're just going to look a little bit different. Okay, let's flip the page. We have another type of function. We call this the square root function. We've actually done a lot of work with this, and it's been kind of a hassle to draw these. So we'll get into drawing more types of these later. Let's make an X and Y chart for this one. Oh my goodness. Okay, so the X and Y points are the important points for this. They're going to look a little different. And that's because, can I plug in -1 here? No, right? Can't take the square root of -1. So I'm going to start with, what is this noise? I'm going to start with x equals 0. Okay. That is so annoying. What is that? Okay. Oh, darn. That's fine. Okay, well, the square root of 0 is 0, right? Okay. We can also do the square root of 1 to get 1. Okay. But if I take the square root of 2, well, that doesn't really tell us anything very easy to graph unless we memorize what it is. So is there another x value that you know? Yes, square root of 4, good. Yeah, you know the square root of 4 is 2, right? So I can plug that one in 2, okay? So we got 0, 0, 1, 1, and 4, 2. Okay, and we can kind of just connect the dots. Remember, the square root function kind of curves outwards and looks like this. Okay, so when I ask you to draw the square root function, it's not the -1, 0, 1 that you're plotting these 3 points instead. Oh, it's back. Okay. Any questions on the square root function? All right. Let's do 1 over x and y. Okay, here's where things get a little complicated, okay? What do I get when I plug in -1 here? -1, right? 1 over -1 is -1. I can plot +1 and that give me +1, okay? So let's just plot those 2 points, the -1, -1, and 1, 1. What happens at x equals 0? Error, right? And what does that translate to on the graph here? It started with an A. Asymptote, right? It's the thing that the graph gets really, really close to, but it doesn't ever reach it, right? So we draw that with the little dotted lines, right? And that's the vertical asymptote. Do you remember where the other asymptote is and what it looks like? Where's the other asymptote? X-axis, it's horizontal, right? So it's down here. Okay. So for this graph, you're going to have to know the 2 points, the asymptotes, and the shape looks like this. The graph gets really, really, really close to both of these. Okay, and it gets really, really close over here. Just like that. So for the 1 over x function, you need to know the points, the 2 points. You need to know the asymptotes and also the shape. So not just the points and the shape, but also the asymptotes. Any questions on the 1 over x function? All right, I'll give you a little moment to write that down. All right, now very similar to the 1 over x function, we have the 1/x² function, okay? So this is different because on the bottom, x is squared and it's not just x to the first power, okay? Let's make a little x and y chart here. Okay, so over here we have our -1, 0, and 1, okay? What happens when I plug in -1 into this function? Becomes +1, right? And if you don't see that, we can also always do this. 1/x² is 1/-1². -1² is +1. So that's why I get +1 here, okay? You don't have to memorize this. You can always just plug into the function, right? 0. Oh, doesn't give me 0. Whoop, messed up there. What's 1/0²? Error, right? Doesn't give me anything. Okay. When I plug in 1, I get 1, right? Okay. So let's plot these points here. We got 1, 1, -1, 1. Okay. I have a 0 error, which kind of means we have an asymptote, right? Let's draw this asymptote here. Okay. And you might have to just memorize this, but just like the 1/x function, we have a horizontal asymptote at the x-axis. So we also have this asymptote. Okay. So I do expect you to know, like, the dotted lines mean asymptotes, know where to draw them, okay? And this function is going to look very, very similar to the 1/x function. It's going to have sort of the same shape on the right-hand side. Okay, and that bottom one just kind of flipped up to the top. So this guy's going to look very similar. It's just in a different spot. Yeah, it's kind of like it's like the quadratic where it can't go below the x-axis, right? But it's like, so everything kind of gets flipped up to the top. So it's a nice observation there. Any questions on this one? All right. Our last function that we're going to learn about is the cubic function, okay? So very similar to the x², but now we have x³, okay? Let's plot some important points here. Okay, x is -1. What's -1³? -1, good. We've got 0, 0, and 1, 1. Right. Okay, so we can just kind of plot these points. Okay, not very revealing here. Now, I don't expect you to know these points, okay, but we can plug in 2, right? And it would give us 8, right? We could plug in -2, which would give us -8. Okay, so these are optional here. And these are really high points, right? If I were to plot 2, 8, it would go all the way like up here, right? And if I were to plot -2, 8, it would be like all the way down here, probably even lower, right? So that's where those points would be. So if I were to graph this, I would have to like try to reach that point really, really, really fast. So you'd kind of curve up on the right-hand side, but on the left-hand side, we would curve down in the same way. Okay. So this graph, I kind of like to say it looks like a disco man because like one guy's going up, the other's going down. Okay, that's kind of how I memorize the cubic function. And it looks like a weird parabola that kind of curves down. Any questions on any of these functions? Okay, so these functions, important things to know are the asymptotes, right? If there are any, know the points and know what the shape looks like. Let's go on here. So we've got vertical shifts of graphs here. So we're going to take these basic functions, right? They're very baseline functions. There's only 8 of them, right? There's not much you can really do with each of those in particular. And we're going to take these basic functions and kind of add things on to them, call numbers close to the
function or inside the function. And it's going to be like a code that tells us what's happening to these basic functions. We can stretch them, we can shift them, we can work them. And it's going to make a nice kind of family of functions that give us more things to work with. Okay.
So first thing we can do is the vertical shift. Okay. And let's just try to read this here. We have a graph of f of x. Okay, so f of x is our function. We're going to graph this function, our baseline function, but we're going to add on a number. Okay.
And notice that this number is kind of set away from the function. Okay, and this becomes important a little bit later on.
If we see this, the graph is going to be shifted upward by c, okay, by any number. So all the points of the graph are going to be shifted upward, and we're going to have a new graph that's above our original graph. Okay. Now I don't like making things like f of x and c. I don't really like that. So I'm going to give you a couple examples here. For example, I don't know, if we had 1 over x squared, right? We know what that graph looks like, and we added on like 4. Okay. Notice how the 4 is like away from the function. It's not like added to the s, it's added to the entire function. Okay. I'll give you another one, like the square root of x minus 2. Okay, that's another example. Notice that the 2 isn't inside the square root, it's kind of set apart from the entire graph. Okay, or like the absolute value of x plus 6, right? So all these numbers are set away from the actual function. Okay, let's do an example here. We have a graph
Of x squared minus 4. Before we start thinking about the transformations,
I want us to think about the basic function that's kind of like underlying this entire
kind of process. So out of the 8 functions that we've gone through the unit class, what's the basic function that's kind of embedded in here? X squared, right? X squared is like the basic thing. There's a squared there.
we know that we're doing something to x squared. Does that make sense? Okay. So on my graph on the left, let's just copy the graph from our first page. Okay. So we're starting with x squared. What are my important points here?
0, 1, 1, 1.
Yeah, -1, 1, this one, -1, 1, and 0, 1. And it's going to look like a parabola, right? It's going to look like a U, like that. Yeah. Okay. So I just drew the original function. Okay. Let's go back to the question. We have x squared minus 4. So we know we're going to do some sort of vertical shift. And we're going to do this by 4. Do you think we're going to go up 4 or down 4? Down, right? Because 4 is negative, right? So because 4 is negative, we're going to go down 4 places. Okay. So the way I go about this is I'm going to start with my important points. So let me just kind of highlight one of these important points. And we're going to shift this point down 4. We're going to go 1, 2, 3, 4, and move it down here. Okay. Now I'm going to translate this to the graph on the right, just so my rightmost graph is my final answer. So -1, -3 is one of my new points. I'm going to take my second point, the 0, 0, and move it 1, 2, 3, 4 down. Okay, going to move the rightmost point, 1, 2, 3, 4 down. And my new point's going to be over here. Does everyone kind of see what I did? I just took each point and shifted them down. All right, and all we have to do is we know the shape is going to be a parabola because the left graph is a parabola. And we're just going to connect the dots here. Okay. Any questions on the vertical shift. Okay, so we shifted it down because it was negative, right? Let's flip the page here. We're going to go to the horizontal shift. Okay, so in this case, we're still adding and subtracting to our graph or to our original function. But over here, it's telling us that we're subtracting something from the x, not the entire function. Let me give you some examples of what this might look like. Okay, so for example, okay, so in our last example, we did a vertical, let me do this somewhere else. We did a vertical shift down 2, and I said it would look like this. Okay, let me show you a horizontal shift. Okay, so if I wanted to shift something horizontally, the 2 wouldn't be subtracted off to the x or to the entire function. It would actually go inside the square root. So it's kind of attached to the x, and it's inside that basic function, right? It's inside the square root. Okay. Now I'm subtracting off 2, and I'm going to kind of try to explain this a little bit better here. If we're subtracting off a 2, we're actually shifting to the right. Okay, I know that sounds kind of counterintuitive. Negative is to the right here. Okay, let me show you another example. If we took the square root of x plus 2, the 2 is positive, we're going to shift to the left. Okay, this is a horizontal shift to the left. Okay, so vertical shifts kind of take away from the entire function. Horizontal shifts are inside of the function and it's attached to the x. Let's do an example here. So we have the graph of the absolute value of x plus 3. All right. First, let's find the basic function. What's the basic function behind all of this? Like out of the 8 functions we have, absolute value function, right? The absolute value of x is kind of like our baseline function here. And just copying the graph from our first page, we have our important points, and it's shaped like a V, right? So our absolute value function looks like a big V. Okay. Now, let's go back to our function here. Now, do you see that the 3 is inside the function? It's not added to the absolute value. It's like inside the absolute value signs. This is how we know this is a horizontal shift. And, by 3. And do you think we're going to the right or to the left here? The left, right? Because it's positive. Good. So we're shifting 3 to the left, and this is because 3 is positive. So same idea here, but we're going to the left and right now. I'm going to take my leftmost point and move it 3 to the left. 1, 2, 3. Okay, so one of my points is going to be here. I'm going to take the rightmost point and move it 1, 2, 3 to the left. And this point is going to be here. Okay, then I'm going to take my 0 point and move it 1, 2, 3 to the left. And my new point's going to be over here. Okay, once I've moved everything to the left, we're going to connect the dots like this. And it's going to look like a V, but it's a little bit shifted over to the right. Any questions on horizontal let's make things a little bit harder. Okay, we're gonna go to the next page. And here we're gonna start piecing things together. Okay, so we have addition and subtraction, but we have two numbers involved here. We have a subtraction close to the x, and we have an addition further away from the function. Okay, so we have a combination of something done horizontally and something done vertically, right? Now, when these are the only two things happening to the function, it doesn't matter what order we're doing this in, but the order is going to matter later on. So my best advice to you, if you're doing a horizontal and a vertical shift, I would do the horizontal shift first. I would move the graph horizontally first, and then I'd move it vertically. Not because there's like a big difference in what would happen, but later on when we put everything together, the horizontal shift is going to come first, and the vertical shift is going to come second. So yeah, let's just do this for now so you get in the mindset of doing horizontal first. Okay. Let's take a look at example 3. We have the graph of 1 over x minus 3 plus 1. What's my basic function here? 1 over x, right? We have a fraction and there's only x in the denominator, so it has to be 1 over x. Using our graph, well, let's see, we have our asymptotes that we need to draw. The dotted lines. Then we have our 2 points, and we have the shape of the graph looking like this. Okay. So this is kind of what our graph looks like, right? Let's go back to the question. And the question's, okay, we have a 3 and we have a 1. Is the horizontal shift dealing with the 3 or the 1 here? The 3, right? Because the 3 is closer to the x, right? The 3 is being subtracted from x. It's underneath the fraction here. So we're going to move horizontally, horizontal shift 3 to the, is it to the right or to the left here? To the right, right? Because 3 is negative. So you're shifting 3 to the right. Okay. And then the 1 is a vertical shift, right? Are we going up or down? Up, right? Okay. So in our heads, let's just take each part of this graph and move it 3 to the right, and then we're going to move it up 1. Start with the asymptotes here. Okay, so we got our horizontal asymptote here, right? Or sorry, the vertical one, the y-axis. Let's see, it says move it 3 to the right. Okay, that's easy. I'm going to move it 1, 2, 3 to the right. Now, can I shift it up? Does it really matter if I shift it up? Why not? Yeah, it goes all the way up, right? So if I move our line up 1, it's not going to do anything. So our horizontal asymptote is actually going to go right here. So I just shifted it 3 to the right. I'm going to take my horizontal asymptote here. Well, I can shift it to the right, but nothing really happens, right? So I can vertically shift it up 1, right? And it becomes up here. So does everyone kind of see what I did here? Next, let's take our points. Okay, we're going to start with this one. Let's horizontally shift it 3 to the right. 1, 2, 3. And we're going to vertically shift it up 1. So our new point becomes right here. And the same thing goes with this one. 3 to the right, 2, 3, up 1, and it becomes right here. Okay. And all we have to do now is draw the shape that's on the left. This shape is awful. I am really bad at drawing. There we go. Okay. So any questions on example 3? A little
more work with the asymptotes, right? But it's the same idea. You're just shifting things to the left and right. All right, how about this? Right example form, I'll be around looking at your answers, and we'll come back together in a bit. All right, let's come back to the front here. Sam, do you kind of want to give us an explanation of your thought process here?
Yeah, so I first looked at the horizontal shift by looking at what's next to it.
Mhm.
The positive three, which can be shifted.
Mhm.
And then I looked at the negative
Mhm. Awesome. Awesome, good. So I saw some people like plugging in the points. You can definitely do that if you're ever confused on how to graph something. If you end up with the right graph, totally fine, but it might take up too much of your time plugging in the values. I think this idea is a little bit simpler than doing that. Okay. Awesome. Let's do our last topic for today. We're going to start talking about these vertical stretches and compressions. So far, we dealt with addition and subtraction a lot, right? We've added and subtracted things to x. We've added and subtracted things to functions. Now we're going to start talking about what happens when we see multiplication going on, right? So there's actually more types of stretches and compressions than just vertical. There's actually horizontal ones, but I don't really see horizontal stretches and compressions much, even like in calculus problems and stuff. So we're just going to focus on the vertical stretch and compression, okay? So vertically stretching and compressing a graph is going to be what we're going to focus on here. And I don't know why I'm losing my track of thought here, but maybe I should go to my notes here. Okay, so let's say that we know the graph of the function. Okay, so we know f of f is true. And we multiply the entire function by something of like C2 or 5 or something like that. Okay. Basically, what we're doing is we're stretching and compressing the graph vertically. And the way I like to think of this is multiplying the y values by a number. This is essentially what's going on here. We're taking the y values and multiplying it by the number. Okay. I think this makes a lot more sense when we deal with an example. So why don't we just go through example number 5? Okay. So we have y equals x squared, but we're multiplying it by 4. So we know this is some sort of vertical stretch or compression. Okay. Now our basic function. Well, I guess that's x squared, right? There's x squared there. So I'm just going to draw my graph of x squared. Okay. And what we're going to do here is we're going to take each of the points and multiply their y values by 4. Okay. I don't know what's the best way to do it. Last time I did it with a chart. Let me try doing it with the coordinates. Okay. So I'm going to take each point and label the coordinates. So 0, 0, 1, 1, negative 1, 1. Okay. And what I'm going to do is I'm going to take the y value and multiply it by the number that's being multiplied here. Okay. So for example, I'm going to replace the y value of the 0 coordinate and multiply it by 4 to get 0. Okay, so my new point is 0, 0. Okay, well, that didn't really do anything. If I take 1, 1, I'm going to take the y value, cross it out, and replace it by 1 times 4, which is 4. So I guess my new point is going to be 1, 4. Does everyone kind of see what I did there? Okay, the third point, I'm going to cross out the positive 1 and replace it by 1 times 4, which is 4. So 1, -1, 4 is my third point. Okay, so you're taking the y value and replacing it with the y value times the number. Okay. Connecting the dots, we've got this graph here. It looks a little bit skinnier. It's been stretched vertically by a factor of 4. Okay. Any questions on example 5? All right. Let's go down to example 6 then. Okay, so this one's a little bit different, but we're multiplying by 1/4, not just 4, right? So let's do the same thing. Our basic function is x squared, right? We can draw our graph again, draw it as many times as we want. Okay, and I can label the coordinates of each of these important points, right? We've got 1, 1, we've got 0, 0, we've got -1, 1, right? And we can do the same thing. We can cross out 1 on the y coordinate and replace it by 1 times, not 4, but 1/4. So the y value is now 1/4, okay? So this point now becomes 1 as our x value and 1/4 as our y value. Now it looks kind of strange on this graph because this is not scaled really well, but I just say 1/4 kind of looks like it's around here. Okay, we can replace the y coordinate of 0, 0 by that y coordinate times 1/4, which is 1/4. Oh, no, sorry, it's 0. There you go. So 0, 0 is our new coordinate. Okay. And finally, we can take the 1 of this coordinate and replace it with 1 times 1/4, which is 1/4. So this coordinate becomes -1, +1/4. Okay. Oops, sorry, I put that, should be down here. Oh my goodness. Sorry, guys. All right, there we go. Okay. And finally, we can connect the dots, right? So our parabola still looks like a U, but it's kind of stretched out, right? It doesn't hit the 1, 1 mark. It's a little bit lower. And the graph is now kind of compressed than it used to be, right? It's kind of smushed down. Okay. So, any questions on our graphs here? So what we're gonna do next time is we're gonna look at reflections. Now we kind of left off here in my last class, so I'm gonna let you go. We're gonna look at what happens when we have a negative